Hi everyone, my name is Adam Benice, and we will be going through how to run the 2D RNA prediction repo. This will simply go through four scripts. One will be to download the dataset, then to clean that dataset, then we'll run the training module, and then we will evaluate the sequences that it will predict for that 2D RNA prediction structure. So first, we will download the dataset. This will be downloading from a Hugging Hugging Face, a public Hugging Face data set called BPRNA. We have it in this train CSV here. Then we will clean the data set. This will go through all the sequences and find all of the sequences that have ambiguous nucleotides. Nucleotides is usually A, C, G, and U. There are ambiguous ones with N, Y, and etc. And we will be removing those to make training easier for our model since our model is more simplified. The next thing we'll do is we will run our training script. This goes through 10 epochs and it has a parameter called max samples of 50. So what this max samples mean is that we'll just take 50 sequences and run with it. So first it will split it into training, validation, and test. So if you see in that terminal that it went 35 train, 7 sequences for validation, and 8 sequences for testing. And then this training will go on with those specific data sets. As you can see in the terminal, you'll see a lot of calculations of MFE and, and and doing some pair probability calculations. What this is doing is the Vienna RNA part of our approved GCNFold architecture. It's basically going through every sequence and trying to find the trying to calculate the thermodynamic priors each nucleotide sequence pair and calculate the probability if there is a pair between those nucleotide pairs. Once this is done calculating, you'll see in this new folder over here of our results. So you're going to see some confusion matrices of each test training and validation sets. We have our loss curve of our training. We also have PR curves. We also have ROC curves. And it shows our hyperparameters for our training. And we also have an evaluation of our losses throughout our training and calculations at um, for final evaluation. Once we have this, we could also visualize it based on 5 random sequences using this script. All we have to do is change this part to find our model. So as you see here, our model will be 2025 513, and then the number 194038. And then we could this will find the model that it uses over here, and will predict RNA sequence structures on 2D RNA prediction based on sequence. This will be outputted into the visualizations folder here. As you can see, we have a PNG file and a text file. The PNG file will give you the sequence that it's testing. This is the ground truth, which is the um this is the matrix of what is given to us in the CSV. Over here is the Vienna RNA prediction with a threshold cutoff. The meaning, based on that cutoff, this is what the final Vienna RNA prediction says it's going to be. It will definitely be um, these pairs. We also have the Vienna RNA base pair probabilities. So there's no threshold cutoff on this, and it will give a heat map of what is most likely, what is unlikely. Next will be our GCNFold predicted probabilities. This is what our model architecture is outputting with no cutoff. So as you can see, we have this black line. This is due to our obvious. So obviously you can't have a pair with itself. And these are our structural limitations that we hard coded ourselves into our model. And as you can see, this is our probabilities, and then this is our final result. Since this final result is not going to be good, obviously, because of the 10 um predict the only 50 sequences and 10 epochs. But if we look at our visualizations over 5,000 sequences, you see better predictions, as you can see here. What is needed for our repo is probably threshold, better threshold cutoffs for each heat map. We probably need to go through a sort of a sweep of what is the best threshold to use for our model. And if we also look, we have a text evaluation of it. So we have the sequence here, how long the nucleotide is, the sequence ID, the ground truth, what ViennaRNA predicts, and what our model predicts. And that is it. Thank you for watching this video, and please let me know if you have any questions. Thank you.